Hey everyone, welcome back to the shop. We have got a job to do for our motorcycle mechanic friend Tim. He has got this custom-made bracket that he made, but he needs a little bit of machine help on it. I'm actually really surprised at how nice this homemade bracket turned out, considering he does not own a milling machine. This was all done by hand with power tools, and it looks fantastic. And it's for his custom build, his Harley Davidson motorcycle that he's working on. And I know that this is a brake caliper that is going on here, but he needs a little bit of help to make this a little bit more accurate where this caliper is going to be mounting up. He needs a pocket milled in here, and he's got it marked where he needs it milled down 165 thousandths. He's got it drawn out. He's actually got the holes drilled already so that it's bolted in there. So we're going to give him a hand with this. We're going to do this in the KBC mill, and I'm going to set up our rotary table to do this, and I think this will be a fun project to share on the channel. So we'll get you in here a little closer so you can see a little more in depth of what we have to do, and then I'm going to take you over to the rotary table and show you. I've been getting it all cleaned up, and we actually have a custom fixture plate for that I bought used several years back, and I've never mounted it before, and now is the perfect time to mount it so that we can use it to hold parts like this in that accessory over on the mill. All right, so we'll get you down here and we'll see what we got to get done. We'll go ahead and remove the caliper. All right, so there you can see where Tim has it marked, where he wants this milled out. If this would have been a nice, even 90-degree angle, it would have been really easy just to clamp it in the milling machine and use your X and Y axis to go in here and mill this pocket out, even mill it square. But it's not 90 degrees, so I've got our protractor out, and I wanted to get on here and see what the angle is. But instead of measuring the Sharpie marks here, I actually put it on the brake caliper itself like this and got a quick measurement. This isn't super, it doesn't need to be super accurate, but we're going to get it very, very close. And what I'm reading right here is if we go past 90 degrees, we're measuring 114 degrees. So if we look at it from a standpoint of being 0 or even 90 degrees, we really only need to, mill it one way, rotate it 14 degrees, and mill it the other direction there on both of those. So perfect job for the rotary table, simple enough. Again, I'm really impressed with the handwork that Tim has done on this bracket right here. The beveling that he's done, this is, I think, is just for looks, you know, just gives it a custom look. And he said he used a router to do that right there. But the cutouts and everything look really nice. So we'll go over to the rotary table. We'll show you what we've been doing with that and see about getting that fixture plate mounted up on it. So this is my dad's old 12-inch rotary table. It is made by Universal Vice and Tool Company. And I've always thought this was an exceptionally high quality tool right here. It's done a lot of jobs for us over the years. I believe I have shown it maybe a couple of times in previous videos on the channel. I don't even remember what jobs we have done on it for YouTube, but I know I've shown it before, but it's always been dirty and grimy and oily. So over the weekend, this was my little cleaning project. I brought it down here from the home shop, and it's gonna live here now. And I'm actually gonna be bringing a lot of different tools down here as I slowly start merging the two shops together. But the job came up where this was gonna be extremely useful. So I wanted to go ahead and spend a little time in getting it cleaned up, which is what I did. You know, got all the grime off of it. This rotary table has some oil holes in here. You can see you have an oil hole here, and then underneath this T-nut, there's another one down in the bottom of that T-slot down there. So we pumped it full of oil. We didn't pump it full. I just put a little extra oil in there as we were getting it cleaned up. But this thing has always felt very nice and smooth. It's got minimal backlash in the worm there. I'm only seeing 2 divisions in our minutes, backlash. So anyway, this is it's nice and smooth. It feels great. You have a lock over here. You have the same kind of lock on the opposite side there, so you can lock it down. It's you can stand this thing up. You have a flange here, so you can stand it up 90 degrees. And I'll show you some pictures. It's real heavy. I don't feel like trying to move this thing around too much. I did weigh it for the very first time, and it weighs 136 pounds. I always hated picking this thing up because it's kind of awkward. There's no convenient place to grab it with your hands. So the best way and the smartest way is to pick it up with some lifting equipment, which is what I'm doing now. But super heavy for a 12-inch rotary table, I think. But the factory actually put hand half-moon flake marks in the mounting surfaces, which to me always kind of shows signs of a high-quality tool whenever somebody does that. Parallel was in the way. I didn't see that. Let's do it again. I want you to look at how nice this thing sits on this table and just glides. 136-pound accessory just sliding across there like you're playing air hockey. Look at that. Love it. We did stone all of the surfaces, make sure there was no burrs or anything. It happens to all these things as you handle them and setting them down. Sometimes there's a little chip somewhere that somebody misses and it'll create a little ding. So those precision flat stones do a really nice job of polishing that. And then those half moon flake marks in there really help hold the oil to the surface for things like this. Got it clamped down with 2 of our studs. We'll get it rough centered up on here in X and Y. The Jacobs chuck work is doing a good job of acting like a center there. Should be within a few thousandths of center. So we'll go ahead and get a test indicator set up and locate this bore. I'm swapping out this collet chuck from an ER40 over to the ER25. This is the size collet chuck that I have always used on the milling machine, 40 taper mill. And it's just within recent, I don't know, the past 6 months or so, I realized I shouldn't have to use an ER40 for every single thing I do. A lot of times this nut and everything is just, it looks massive against the cutting tools that you're going to be using, especially if you're using small diameter stuff. So I went ahead and got ER16, ER25, and ER32, so I'd have a full set of collets for the KBC mill. And I was going to point out that this is the TMX brand. These are made in Poland. I've always found these tools to be high quality. If you're looking for some good collet chucks for your milling machine, check out the TMX line of tools. I'm getting our Starrett number 811 test indicator set up here. Great feature about the number 811, you can rotate the dial face up so that you can just simply stand in one place and be able to look down at it and see your reading. Looks like we've got it sweet within a half a thousandths. That should work well. Now we'll go ahead and get our fixture plate mounted up, give it one more wipe down, make sure there's no dust settled on it. And we're going to go ahead and throw a layer of our SP350 on there, corrosion inhibitor. I don't plan on unbolting this right away, so I think it's just going to stay on there for a while. This is going to help keep any kind of rust or corrosion from forming. I'm going to go ahead and see if we can get all of our bolts lined up, and then we'll go ahead and sweep this one as well, make sure that our fixture plate is also centered on the axis of rotation, because whenever we use this, we want to make sure that whenever we come over here to use this, that this is in the center so that we can locate the entire rotary table based off the center hole that was machined in this fixture plate. Rotate this around so it's easier to see that one on the back side. And to get it rough centered, we'll put our center point in here. I already got a 3/8 collet in there for our center. Let's see if we can get this last one lined up. All right, we got all 4 of the bolts in there. I had to loosen them up and shift it around so I could line up with them T-nuts there. And let's go ahead and just get it centered, rough centered with our center point. Not going to go down far enough, is it? There we go. That'll hold it center. Okay, we got all 4 bolts in there now. I had to take 2 of them out so I could get the other 2 lined up. So we're going to go ahead and we're going to use our center point here to line the plate up in the center. And what I'll do is I'll just go ahead and snug these 4 lightly. And I'd like to run the indicator back in there and see where the plate is sitting, if we need to bump it a thou or 2. Go back in with our stair at 811. Looks like -1, I'm sorry, +1, reading it upside down, +2, +1, +2, +1, +2. We'll get a dead blow and see if we can tap that and get it centered a little bit better. It's all about a 1/2 thou movement, so we're at 1.5. That looks like nearly 1.5. Let's see if we can go that way just a touch. Two and 2.5, and we've got 2 and 2.5. I think that's going to be plenty good where we have it right there. I'm going to say that's probably well within 1/1000th of being centered on our rotary table. Go ahead and give it another sweep here. That's looking good. Let's call it where it's at. I'm going to take our indicator out, and then I'm going to go ahead and torque those bolts one more time. Make sure that the plate is nice and tight. We've got our fixture clamped down in the center. It is ready to go to work. So we got our aluminum bracket to mill, and I've been trying to think out which orientation, the position that this might work best in. Got to consider a couple things. I want to be able to see this red line. That's my indication right there of where we need to move our cutter to. So I think we may clamp it in this position right here, mill this side, and then we'll just repeat it like this. We'll just move it around and reclamp it. Now that we got our really nice fixture on here, once we get this set, I can put 4 little strap clamps on here to hold it down. But to give you an example of what we're going to be doing, we're going to use our center point to find the center of the hole. We're going to use that as our center of axis on our rotation. So we'll bring that down gently. And what we will do is kind of we'll get like this line right here in line this way with our x-axis there. Get it clamped where it needs to be. And we'll start over here on the left side and mill in to the corner. And once we get there, we can take our rotary table and go ahead, and we're just going to rotate it our measured 14-degree difference. Just go to 14 degrees, and then we can move our Y travel toward us and cut this side right there. Probably make a couple of passes in there, and then maybe one to clean up the wall. And then so once we're ready to go back out, we just simply rotate it back to 0. And I know on the hand wheel, it's actually 10 minutes, but it's 2 divisions on the dial here. So go 2 lines, and the backlash will bring you right back exactly to 0 every time. So that's our setup. I'm going to go ahead and start getting our strap clamps and studs figured out that we need to hold it down. So we have these little brass strap clamps. We got some brass pads. You can adjust the height of it, get it nice and level with that screw on the back. So I think that's going to be a good position right there. So we'll go ahead and remove this set screw from the fixture plate. Put this over here on the workbench so it doesn't get lost, hopefully. I've already got some of these studs pre-cut from previous jobs. I think it's going to work. Put a washer and a hex nut. Get it level with the adjusting screw on the back, and then just tighten it down just like that. So I'll go ahead and repeat that 4 times wherever we can line up at. I am wanting to use the 1/4 inch studs on this plate, so I think that might be a little bit close right there. We may have to use this one here. Oh, this one's missing the pad back here. That one's a little bit too short. I may have to cut some more. This is how this fixturing goes, but I keep some all thread in the toolbox, so whenever we're doing little setups like this, we can just cut custom length studs, dress the ends, and then once they're done, I just put them back in the little toolkit right there that they come in. But you can see what we're doing. So I want to repeat this. I think I'm going to cut a new stud for this guy right here, but we're going to do this 2 more times on the back side as well. We're going to test this one, see if that's a good length that I cut there. 1 3/4 inches long before I cut all 4 of them. Yeah, I think that looks good right there. I'll do that 3 more times. All right, that's looking pretty good right there. Now I'm not going to tighten it down fully yet because we need to go ahead and get this one of our lines indicated in the X direction there. So we'll do that next. All right, I want to show you my setup that we're going to be using to try to indicate the line, the red lines straight. What I have done, I have taken the parts off of my Starrett number 257 surface gauge. So we have the scriber. This is the number 57S snug. You can use this on different size rods. And I want to leave the center down in the hole so it doesn't move the part off of the center axis there. But you can see we have our scriber lined up down there on the line. So what we're going to be doing is a visual indication of this. What I'll do is we will move the center up out of the hole like so. And then we'll just go ahead and crank it down like this. And I can tell the point of the scriber is off of the line, so this needs to get bumped around. But that's why we need to keep the center in the hole. So we'll just come back to our 0 on the DRO like so. Run the center back down in there like that before we bump it around, and we got a little soft blow we can use to tap it like we need. All right, so this is a little bit hard to show, so I just thought I would go ahead and show you what the setup is looking like right here. All right, let's see if you guys can see that. We're gonna go ahead and move our center out of the way and crank our table down to the end there. It looks like it's off not very far, maybe about 20, 30 thousandths. I'm gonna see if we can get you zoomed in a little bit more. Let's just go to 2. How about that right there? Go back to our 0 so you can see what we're talking about. All right, that would be our center of rotation. All right, so because I don't want to risk moving this thing off center, we're going to go right back to the center here. And I'm just going to go ahead and bump it slightly, rotate it around. Let's give it another check. Still off. Need to go a little bit more than that. It's getting close, but we still got a few thou left to move that. So let's go back to our center. Very close. I think one more little bump and we should be close enough. Try that right there. I'm gonna make sure you guys can see it. I'm on the other side. Okay, I think you can see that. Pretty darn close if you ask me. Maybe a few thousandths. If it is, it's not much. One more little tap and I think we should have it now. Yep, that's looking good. Do you think that is close enough? I think it is, especially since we're milling a clearance in this pocket for the caliper to go in. But I think that's gonna work right there where it's at. So from here, we're gonna go ahead and lock down all of our toe clamps and make sure this is tight. And I think we'll be ready to start milling. So we need to figure out what size cutter that we're going to run for our operation. This is the radius that we want to match up right here with our cutter. So we just pulled out our Starrett radius gauge set, and this is the 5/16 radius gauge, and it fits pretty darn close to that right there. It fits closer than the other ones. So we are going to use a 5/8 diameter cutter for this operation. Checking that side there as well. Fits up nicely. So what we're going to use, I've talked about this before many times. I love my Tungalloy tongue force rec. I have a 5/8 right here. They make these from, I believe, 5/16 up to 1 inch in the mill shank style, and then over that they have them as a shell mill style. So we're going to use this 5/8 tongue force rec, and I have the aluminum cutting inserts installed on there. So hopefully this will do a good job. And these are made to cut very, very close to the nominal diameter of which they are. So we'll get this installed in the mill, and we should be just about ready to start making some chips. If you don't have your radius gauge set, make sure you have some. Okay, we've got our tool loaded up. Let's touch off and get this thing cut. So he wants a total depth of 165. It's not super critical, so we're just gonna touch off. We're gonna take 165 on there. And I'm gonna do 3 cuts, so divided by 3, that's 55 thousandths per pass. Got the mill running 2,000 RPM. We get a 0 set here now on our knee. $55. Coming into our 0 on the DRO. Now we'll go to 110. Take another pass. Now we'll go to 165. I'll make sure that I don't touch that other side. On 65. You know what? I'm going to drop that. I'm just going to drop it 10 thousandths. And what we'll do is when we mill the other side, we'll mill all of it at the same depth. Just stop that so it's not so loud. All right, I feel good about our cut there. We may move in 10, 15 thousandths and clean that wall up, take a little bit of that line out of there, but I want to go ahead and get the other side cut first. So let's go ahead and rotate our rotary table here. We're going to go 14 degrees. That's 10, 13. All right, there's our 14 degrees right there. Bringing it back into our 0 on X. Go to our 0 on Y. I think that turned out great. I think we just need to take a little bit on that red line there and we should be good to go. All right, we're going to take 10 thousandths for our finish pass. 165 right there. All right. I'm going to take an extra 10 on X here. go an extra 10 and wide. We'll hear it scream just a little here. All right. Coming back around to our 0. Got one little notch in there that we need to cut off. That should be it right there. I think the cut went really well. It looks good, and it should be exactly what Tim wants there. So we're gonna go ahead and break this down. I'm gonna duplicate the setup that I already showed you do. So we're just gonna move our strap clamps. I'm gonna rotate this thing around, 180 degrees, get it lined up in the center of that hole, use our scribe to get our X in line, and then replicate the cut on the other side there. But since we already showed the complete setup, I'm just gonna go through here and get it done, bring you back whenever we start moving these hand wheels and making some cuts. Okay, we've got the second side set up now, and I think I've got it indicated straight, so we'll go ahead and give you a little video of that. You can see, watch our scriber there. Looks to me like it follows that line pretty closely. All right, we're ready to cut the second side. There's our touch off. We'll do the same thing, split into 3 cuts, 55. come up for our final cut. I believe we should be finished up with this, so I'm going to call it where it is. Go ahead and get the cutter up out of there, and let's just, I'm just going to go ahead and take it off. I have no way of, I can't fit the caliper on there with it bolted down, so we're just going to take it off. I went an extra 10 thousandths past our zero both directions there to try to cut a little bit more of that red Sharpie out of there. So I'm hoping that there's adequate clearance for it to fit down in there and the bolts go in. We'll go check it and see. Worst case, if it's a little too tight, I can set it back up and take a little bit more. But he did ask to try to not cut through the sides there, you know, where the radius is. And it's just right up to the edge. So I was trying to be really careful not to break through there. Let's just take them off out of the way. I think that looks nice. Still have to deburr it, but let's check it and see if it goes on there. All right, there's our caliper, and it should fit on this way. Definitely fits down in the pocket. See if the bolts line up. Look at that. It's like it was made for it. The clearance around the outside of it, I'll get you a picture so you guys can see this, but the gap between the caliper and the bracket itself looks uniform. It looks like we have 15 thousandths or so, and the angle lined up beautifully. Like I said, I'll get a couple pictures so you guys can see that. That worked out nice right there. Hopefully by the time you guys are watching this, I'll have a little bit of extra info that we can throw on the screen so you guys can know maybe what bike this is going on. I know Tim told me what it was for. I just can't remember what it is. I know it's an older Harley Davidson. whichever models originally came with the chain drive, I believe. I'm sure he is going to like that right there. We did it. We give him exactly what he asked for. Nice. I'm going to go ahead and get my mess cleaned up right here. I'll bring you guys back and give you some final thoughts on this. Got a couple of Noga deburring tools here. We use this to deburr these holes. You have to be careful with this guy because they will pull themselves down in that material and go deeper and deeper. That looks good. All right, that feels good. It should be good to go. All right, guys, that's going to wrap up this little project right here, modifying this little aluminum angle bracket. And I'm sure our friend Tim is going to be really excited to hear that this guy is now ready to go. I think everything turned out just as he was wanting it to be, and he's going to be excited to get it back. This was a fun little project. You know, we could have very well put this in our CNC mill, clamped it down and done the milling that we needed, but honestly, it was taking even more brain power on my end to try to figure out the best way if I was going to do that in a CNC mill. I know I could have figured it out, but I also know that a lot of you guys watching really enjoy seeing the manual machining and the setups involved in doing jobs like this. And I decided that's what I wanted to do. I was looking for a good opportunity to go ahead and get our rotary table cleaned up, you know, Dad's rotary table, get it all cleaned up. We did that, made some T-nuts. That fixture plate that I bought a while back used, I knew that I wanted to put it on that, and we finally had a perfect job to show how well that fixture plate turned out. Now, it's still over there on the mill, and I'm just gonna keep it on that rotary table. It's the perfect match for it. That with my little clamp set that I've had for a while. The tongue force wreck, the little end mill here, did a fantastic job. As I said, you can pick these up in a variety of different sizes and different carbide inserts there, and they all use the same size insert, so you can get a pack of these inserts and have a few different sizes of these end mills, you know, and they're all going to use the same cutter, and they work fantastic. So you can use them in the manual machine, use them in your CNC. They're even through spindle coolant there as well, through tool coolant, I mean. So anyway, that's going to wrap this one up. As I said in the previous video, we have another really great project to work on for Tim, where we're going to be making an adapter for his brake hub, where he's going from the original chain drive to a more modern belt drive. So we have to do some machining of a pulley. We have a plate of aluminum that we've got to actually cut out and machine into an adapter plate. I believe we're going to have we're definitely going to have some lathe work, and I may use the pacemaker just because of the bigger chuck holding that piece of aluminum that he brought me. And we'll have some mill work involved there too. But we'll get to that one real soon. But for now, this one's finished up. I hope you guys enjoyed watching, and I enjoyed sharing all of this with you on this project. And I hope to see you back here on the next one. All right, we'll see you then.